In the last lesson, we saw how we could use the Cloud Firestore to start saving our users' messages to our cloud-based database. In this lesson, I want to show you how you can read from the database so that we can populate our app and all the message bubbles. If you take a look at the documentation under the Getting Started section of Cloud Firestore, you can see that it has a section on reading data. We can again use our database reference, tap into a collection with a particular name that exists in your database. So in our case, it's messages. And then we can call get documents to get hold of the documents in that particular collection. We've currently only got one document, which is this test message right here. And I want to be able to show that test message when we load up our Flash Chat app. So I'm going to log out and go back to the home screen, and I want to be able to modify the code so that inside view.did_load, when that chat view control is being loaded up, I want to call a method called load messages, and this method, load messages, should be able to pull up all of the current data that's inside our database. And then we're going to use it to populate our table view. So the first thing that should happen when we're loading messages from our Cloud Firestore is we should clear these dummy messages. So let's go ahead and set this messages array to an empty array so that we clear it out. And the next thing we're going to do is we're going to tap into our database. So we're going to say db.collection. And remember, the collection path is going to be using that constant k.fstore.collection name. And then we're going to call that method that we saw over here, which is getDocuments. So let's call getDocuments, and it has a completion block. With this completion block selected, let's hit enter. And you can see that we get two things back once this process of getting documents completes. One is a query snapshot. So we'll just call that query snapshot. And then the other is an error if there was one. So this is an optional error. It will only be equal to something if there actually was something bad that happened. So in our code here, we're going to check to see if let e equals error. So if error is not nil, then we're going to print there was an issue retrieving data from Firestore. And then we're going to add on that e at the end to print it out as well. But if there were no errors, then we want to be able to tap into this query snapshot object and get hold of the data that's contained inside. This query snapshot is actually it's an optional query snapshot. So if we wanted a little bit more detail on what that thing actually is, then instead of going into the guide section, we can go to the reference section on the Firebase docs. And if we go into iOS Swift and locate the Firestore section, and then if you go into classes and scroll down, you should be able to find query snapshot right here. So this is an NS object, and it is created from a class called query snapshot. And this has a bunch of properties like the query on which you called getDocuments, or the metadata, or whether if it's empty, or the count of documents inside. But the one that we want is actually this array called documents, because this contains the actual documents that's saved in that collection. Coming back over here, let's go ahead and tap into our query snapshot.documents. And this, as you can see, is an array of query document snapshot objects. So what if we wanted to see what a query document snapshot looks like and what properties does it have? Well, then we can try and find it inside the Firestore classes, and it's right here. So it tells us that the document is guaranteed to exist and its data can be extracted with the data property, or simply by subscripting the array. That means we can either say square brackets 0 to get the first item from the documents array, And then we can tap into the data property, which notice it's now a dictionary with a key value pair. So as long as you know the key, say for example in our case we had a k.fstore.sender field, then we should be able to get the value of that piece of data. But our code is now looking quite terse and it's kind of hard to understand what's going on. So let's make this a little bit better. Now we know that the query snapshot is an optional. So let's first use an if-let to bind these documents, if they exist, to a new constant. Let's call this snapshot documents, and we're going to set it to equal query snapshot $documents. So now we have this snapshot documents, which is an array of query document snapshots, and it's now fully unwrapped. So the next step is to loop through this array of document snapshots and to be able to tap into the data of each of them. We can, for example, create a for loop and say for doc in snapshot documents. So for each of these documents in there, we're going to go ahead and print the doc.data. And this data is now a key value pair. So let's go ahead and run our code and see what we get printed. So as soon as it loads up, we get our data printed from our documents, and it has a body of test message, a sender 1@2.com. And if we go ahead and send another message, say testing, hit send, and it successfully saved our data. So let's log out and log back in again to trigger that view did load. You can see this time we're now getting both messages printed out because of our for loop. So we're looping through all of the documents inside this array, and for each of them we're tapping into the data object and we're printing it out down here. So instead of printing that data object, what if we could save it as a piece of data? So let data equal doc.data, and then we can divide up that data into the sender value and the body value. So we can say let sender equal data, and we're going to access the value using the square brackets because it's a dictionary, and we're going to tap into k.fstore.sender field. Now remember that when you're working with dictionaries and when you're trying to retrieve things from dictionaries, because we're using a string to retrieve that piece of data, and there can obviously be typos in the string, then the item that we get out, or the value, is going to be again an optional. And even worse, it's not just an optional, but we don't even know what the data type is, because this data has a data type of any. And the reason is because Firebase allows us to store lots of different data types into the database. Say we could have had a field called time, right? Like when the message was sent. Well, that obviously wouldn't be a string. So the flexibility on Firebase's part makes us have to do a little bit more work when we're trying to retrieve the items. So we know that the sender data is going to be a string. Instead of having a optional any, I'm going to use the conditional downcast to cast it into a string. Now we should have an optional string instead. So as long as we're able to retrieve the sender field from our data, then we should end up with some sort of string. So what we can do is we can use an if-let to bind this sender to this value right here. And in addition, I'm also going to tag on a constant to save our message body. And this is going to be set to equal data and a set of square brackets and then k.fstore.body field. And then here, this is also going to be a question mark any So we also have to conditionally downcast it to a string because we know that the message is also a string data type. So if both of these pieces succeed, then we should end up with a sender that is now a non-optional string and a message body, which is also a non-optional string. So we're now ready to create a message object using the message class because it has two properties that need filling, the sender and body, and we've now got both of them back from Firebase. And once we've typecast our sender and message body to strings, then we're going to create a new message, which is going to be created from the message class. So this one right here with a capital M. And then we're going to initialize it with the sender being equal to this sender. And if you want to make it just a little bit more clear, which one is which, then it might be easier if you have it as message sender instead. So you can see that we're creating a new message, and for the sender property, we're giving it this value, which comes from right here. And then the body we'll set as the message body. And now we've got a new message ready to add to our array of messages, which is currently empty. So let's go ahead and do that. Let's tap into the messages array and append this new message to it. So we should now have a message array with 2 items. And because we're inside a closure right now, we have to, of course, add the keyword self in front of messages. So now we no longer need these dummy messages because we're going to be getting the live messages that are coming back from Firebase. Now notice how we're calling load messages inside viewDidLoad. But the time point where we add our message to our messages array actually happens inside our closure right here. So our closure could be triggered at any point, and it really depends on your internet connection as to how long it would take for you to get back these documents. Very often what you'll find is that even though this is being triggered right at the point when view is being loaded up, the message is not added in time for it to be shown inside the table view when it starts tapping into the messages array and populating each of the cells. So when we run our app, you can see that despite everything we've done, we're still not seeing any messages show up here, and it's actually completely empty. So what can we do? How can we trigger our table view to call these methods again and reload the table view? Well, there's a method for that. So once we're done appending our message to messages, we can go ahead and call tableview.reloadData. And what this will do is it will be able to tap into the table view and trigger those data source methods again. But because we're inside a closure, we have to add the word self in front. And remember, another good practice thing to do is whenever you're trying to manipulate the user interface, like in this case when we're trying to update the table view, and you're inside a closure, a good idea is to get hold of the main queue. So we can say dispatch queue.main.async, and then inside this block is where we trigger the update to our table view. And this just ensures that because this process of fetching documents happens in a closure, that means it's happening in the background. And when we're ready to update our table view with the new messages, we have to fetch the main thread, which is the process that's happening in the foreground. And it's on that thread that we actually update our data. So let's run our app and let's see if it works. So once we've logged in and we've gotten hold of the messages, it took maybe a fraction of a second for it to load up, but we now see our test message and testing show up on screen. And the one last thing that we should fix while we're here is notice how when I type a new message and I click send, nothing actually happens in our table view, even though we've successfully saved our data. So what do we need? Well, we need another call to get documents. Or alternatively, we can use another functionality that Firebase has, which is to listen for changes in our database collection. And that is what we're going to tackle in the next lesson. I'll see you there.